Thank you. Okay, so we are going to talk about the Video-ChatGPT and PG-Video-LLaVA. This is lecture 7. And just to remind you that in lecture 4, we discussed clip, Koke, and Pali. And then lecture 5, we discussed Flamingo, Flava, Painter, and Blip2. And lecture 6, we discussed image bind, language bind, and lava. So all these were based on the images and the text. Now we're going to talk about video and text. So Video-ChatGPT and PG-Video-LLaVA from the same group, from MB Zwei University. So then lecture 8, which will be next Monday, we'll talk about Video-LLaVA and Shikra. So that'll be end of the part 1 of this course, which will be this visual language models. Then I will start talking about the diffusion models, because this course is about generative computer vision, the VLM, and diffusion model. Both of them generative models, of course, very different. The diffusion model generate images, but here generate language, mostly a text. But input can be image and a text. Okay. So this is the paper published in ACL, which is the NLP conference, American Conference of what? Computational Linguistics or something? Association of Computational Linguistics. So this is the first, in a way, video conversation model, pretty simple. And the main thing here, the contribution is that they have come up with the annotation framework to annotate the videos, which is required for the VLM, video VLM. And in particular, they have generated 100,000 high-quality instruction data for videos. Okay. So as we talk about the language model, LLM is already trained. It will predict the next word. It will give you language. Now, in order to make it a chatbot, then you have to have instruction fine-tuning. You have the question and the answer. So you input a question, then have the LLM predict the answer. Okay. Now that's what from GPT going to ChatGPT was basically that, the instruction fine-tuning, so that you can do conversation. So same thing if you want to do in VLM, then we have to have question-answer pair for the images. And here we want to do for video, so we want to have this high-quality instruction data set for video. And that's what they did. And also, as we talk about, the most important thing is that when you generate these models, how do you evaluate those, right? Because people are happy you can come, ask question and answers and everybody's using. But as a scientific research, how do we know that this paper A method, which is described in that, compared method B described in another paper, how good they are, which is better? How do we analytically, scientifically, objectively evaluate? So that's why we need some kind of quantitative or qualitative evaluation. So this is the model. It's pretty, again, very simple, following the LLaVA. So we have the video, and video is sequence of frames. In 1 second, we have 30 frames. So it goes to the encoder. So we want to encode, and this is the image encoder, clip encoder. And we'll talk about how you take these image encoding and convert in the video clip encoding and linear layer, and they have system command and query, and then it goes to the LLM. And at that time, they use Vicuna, and it comes out the output. Okay, so now let's look at the video encoder. So main thing is that you can extract the features of each frame. We can treat each frame of video as the image, and we have clip, which will give you features. But the thing is that how do you find the features of a clip, find out of the video? So that's the main thing. So that's why we need a special temporal feature, because the clip will give you only a special feature. Now there's a temporal features, and how do you do that? So they are using two kinds of pooling, spatial pooling and temporal pooling. and which is shown here. And so then combining those, they get the features of the whole clip. So I'll go in detail. So each clip, which is a sample, video sample called XI, has T frames, uppercase T, and it has H tokens in each frame in the horizontal direction and W tokens in the vertical direction. So H multiplied W are the tokens, and we'll represent as N. So the N tokens each frame, and then we have the D is the dimension of a token. As we talk about, you can 16 by 16 page and RGB, about 768 dimensional feature vector. So N is the number of tokens. So now what we are going to do, we will do average pooling across temporal dimension. Okay. So what that means that we will take, suppose this clip, and we will take each of the token and go in temporal like this, and we'll get one token. We'll take a second token. We'll go to all the frames in this clip. We'll get a second token, and so on, and all that, as shown here. These 4 frames in a clip. This example can have any number of frames. This will be representation of this particular clip, which will represent TI. Okay. So in that one, we will have N tokens because each of the frame has N tokens, and each of token is a D dimension. So that will be representation of this clip, which is shown here. And this we are doing the around a temporal dimension, because we take the each token in different frames of clip, just average them, and we get one token. We take the second token, we average them, second token, and so on. So then we are going to also do the spatial, I was pulling a spatial dimension. Okay. Now what's going to happen, that we will take all the tokens here in each frame, this frame, and average them, we'll get one token, which we'll put here. We will go to the next frame and average them, we'll put a second token here. And we'll go to third frame, we average them, we'll put here. So this will be a representation of this clip, and it will be a spatial feature, and there's a temporal feature. So this will be the T, because we are talking about the T frames in a clip, and again the token dimension D. So therefore we combine them, the spatial token, spatial representation and temporal representation, and concatenate. Now we will have T plus N tokens, and each of the token is D dimension, and that is representation of the clip. We'll do the same for every clip, and that's it. So that is, once we have that, then we will have a linear layer here, and that we will train or fine tune. That's why it's, show the fire symbol, and then go to language model, large language model, which is Vicuna. Okay. So after that, we'll get the output Video-ChatGPT. So system command will be, you are the Video-ChatGPT, a large visual language model trained with the video instruction data, and then user will ask, where is this video taken from? Then it will respond, this video is taken from New York City, especially in the vicinity of Statue of Liberty. The statue is shown in the background, and the video also shows the city of skyline background. That's it. Okay. So now the main contribution of this work is that they came up with the human-assisted annotation. And so first thing is you have to identify which data set you want to use, because this ActivityNet is data set, which is larger than the UCF 101 or HMD 51. So they took that, and for that, they already have some captions. Each of video has some caption. And now they enrich that captions using the human annotators, and they included special information from physical appearance, spatial and temporal localization, and so on. So this is one of the video from the ActivityNet, and this was the original caption, because ActiveNet is a bit older data set, of course newer than UCF 101. But at that time, the captioning wasn't working that well, so they got this one. So what they did is human annotation, so it's much more detailed and talks about a lot of things about this video. And that makes a difference. This is another example. Again, the original data set annotation very small, pretty few sentences, but here you have much better annotation. So they can compare that in this one, they're talking about as a camera pans, lush green branches, enjoying each other's company, and festive after they finish hanging ornaments and so on. There's a lot of detail. You have a question, JB? Yeah. Oh, okay. Okay, so so that's what they have. So now they will talk about how they enrich the ground truth caption using off-the-shelf models. So first is they use the blip2, okay, which we discussed, and you guys did you are going to do the assignment. So it will give you, given an image, it will give you caption. That's one of the output of the blip2. You can use that for. Then there's another method called grid, which will give you the caption for scene object. What are scenes objects present in the image? Then they use another one called tag to text, which will give you tags of each keyframe. So using those three, then they want to come out with much more enriched caption for this ActiveNet. So they also ensure that you have because these programs will give you some tags or some caption, but they apply some threshold to get really good quality, high threshold, to get a good quality prediction. So they remove captions which were not matching with the tag to text, because tag to text tell you what are the tags you can assign to this frame, but blip2 tells you what should be the captions and so on. So they want to have these three pieces of information which will be consistent and remove some of the noisy one, which is a good idea. And then they took those captions and give it to GPT 3.5 to summarize or get a coherent caption. So these are different steps they do. Okay. So here is the final results. And then if you look at that, they have much more interesting for this one, woman standing in the arena. The countdown continues to show more members and clips of people playing dodgeball, spinning, turning before. So in order to generate this chat part, you have to have a lot of information about the video so that the LLM can use that to be able to answer questions, right? Because that's the biggest problem when you do vision. It's images, and images are numbers, pixels, or frames. So it's different than the words in the NLP. So now what we are doing here, taking these numbers and converting them captions and making sure there's caption right, then we can do conversation. Okay? So here is the thing. Let's see if it's going to play here. This is the TV show. So how do I turn on the volume here? It has to be speaker, right? So which is speaker? Do I have to do that or not? Check the speaker too. Where's the speaker too? Can you come?
I'm still learning.
Okay. So you like it?
One, two, three, four.
Okay, so this guy was he's dead, right? So did he commit suicide or he?
You know the song. Sing along.
So this is the show. Now you want to talk about be able to do conversation about this, right? So for this clip, the original data set, this is a clip from the okay? So original data set is a man
So?
is playing bagpipe in front
No.
of people on the couch in front of him start laughing. Okay, this is not that useful. But they came up with this information. So first is blip 2 give you these kind of information. 3 women are sitting in a couch, a woman, and then a grid description give you a woman in a pink and where that is, the bounding box here. Okay, then the tags, the other source, it tells you in this image there's a table, there's a couch, there's a pajama, and so on. So you want to combine all these for every frame. This is another frame, a man and woman sitting in a couch, men sitting in a couch, 2 women sitting in a couch, and things like that. Man is black shirt, a front of television. So you want to take all this information and come up with much more detailed captions. Okay, so from here they want to remove noisy information. Okay, so suppose here it says flower patron holding a remote. It's not there when they verify. The human look at it, say, well, in this frame, in this video, is there? It's not there. So they remove it. Okay. Suppose on phone there was nobody on the phone. So things like that. So then now it's a cleanup and you get a better captions. Okay. So given these captions, then now you want to generate the question answer pair to do the instruction fine tuning of this model. So now how do you generate a question answer pair? So this again you are going to ask the GPT 3.5. So they give a directions that, well, you should have detailed description, you can summarize question answer pairs, tasks that stimulate creativity or generation of new ideas, conversational task, and so on. So these will be the output from the GPT. Give you this question, and then this should be the answer. Okay? Then for this video, this is the question, this is the answer. You get lots of these question answer pair automatically from the caption. Input a caption, give direction, and generate those. Okay? So these are example of, can you summarize the events in the video? And the answer is that, yes, the video shows a man playing bagpipes and so on. Now, these are for training. Okay? So you will give this question, they will give this video, and then ask this model to predict this answer. Okay, so you train it. So that's what called instruction fine tuning. Okay, so things like that. This dress in a black shirt and from television and so on. So now once it's done, then you want to evaluate this and quantitatively. So they also introduce this matrix that there are 2 types of evaluation. So one is the video-based generative performance benchmark, and other is the zero-shot question answering evaluation. So we'll go through that. So now one is that you do the training. So you have question answer pair for training. Then there's another data set, question answer pair for testing, for evaluation. They are different. Okay, so they created another set for test set from the same data set. And again, another detailed description and so on. And then evaluation was done by GPT 3.5. Right? You see the GPT keep coming up different ways. It generated a question answer pair. It can be also used for evaluation. Okay, and of course there's a large language model within GPT. So they give you various capabilities of model. They give you relative scores to the generated prediction from 1 to 5. So they give this direction that this answer should be correctness of information, detailed orientation, contextual understanding, and temporal understanding, and the consistency. And then they define what we mean by the correctness of information. So you give this direction to the GPT. Say, verify accuracy of generated text and so on. So a good thing is that since GPT understands language, you can just describe a sentence. But otherwise, you have to come up with formulas and so on. So which is interesting. Okay. So the correctness means that you want to align with video content. The answer should be, looking at the video. And detailed orientation, that it should be complete, and meaning the model's response covers all major points from the video, and so on. Contextual understanding, context of video content, temporal understanding. There is temporal of sequence happening, sequence of events. So you should capture that and all this thing. And also consistency, that you can have the similar, consistent answer for similar questions. You should not get confused, similar, in a way, meaning similar question you ask, but you get a very different answer. Okay, so these are the directions they gave it to GPT. So role, what is role of that? What is your intelligent chat part designed for this, all this thing? Focus on factual consistency and predict the answer must be factually correct and all those things. So you have to tell all these, and it works. So using that, they compare with those models which were available at that time. So video chat, Llama adapter, video Llama, video ChatGPT, for these 5 different aspects, and they found out that they did pretty well in all those. They did better than all those methods, which was good. So then also they conducted zero-shot evaluation on open-ended question-answer dataset. So MS or VTT question-answer, MSVD question-answer, TGIF question-answer, and so on. And then activity-needed question-answer. So there are lots of these which people have been using, not necessarily for the VLM, but they use there also. Zero-shot means that this, of course, in ActivityNet, they use some other video, but these did not use, so it's in a way zero-shot. So then again, they use 3.5 GPT to get a score from 1 to 5, and these are the results. So one is the score, other is accuracy, yes or no, and they found out that Video-ChatGPT does pretty well, in all these metrics. So then they also look at the fun question answer. So this is the benchmark, which has some humorous question answer, some magic question answer, creative, and so on. And their metrics are different, which basically are just comparing the text. So before ChatGPT, typically in NLP, used to compare 2 strings. And these were the metrics, the blue, ROG, and all those things, cider, how similar 2 sentences are, 2 string of words. So those are the models that, evaluation they are using here. And in that also they are doing reasonably well, as you see in this here. Okay, let me put this. So they compare with video chat and the other method and so on. So they get a pretty reasonable results here. So now these are some of the examples. Suppose this is the video, and you give this video. So the video on? It's not. It's going up. Thank you, everybody. Okay, so that's the idea here. So why this video is funny, and maybe let's try this one then. No. Okay. So this, you give this video, and then after that, then you will get the, what's happening here? Submit or something? Yeah, this video is funny because the little girl is reading a book while wearing a pair of glasses and all this thing. The combination of her glasses, pink shirt, and all these things. She's reading a book, but there's no pink shirt, right? Okay, so this is another example or something. Let's look at this one. Oh. Yeah, there used to be a video, there used to be an audio, so I don't know what's happening here. It's playing, but anyway. So this is another video. What is strange about this video? The video is strange because it shows a man and lion interacting in a way that's not typical. The man is seeing the lion and so on. So that's unfortunate. You are not able to see this, hear that one. Was it here something? No, there's nothing here. Okay. Well, so this is another one. There's something, we can hear. No, there's audio. I have played it in my computer. Yeah, speaker is wrong, right? Yeah. So, okay. So I think the otherwise, if you play, this is very, very nice fun. Okay. So then this is the example. Can you identify any safety hazard in this video? And yes, this is a safety hazard video. A child is playing with a toy, and there's a fireplace nearby. The child is sitting on the floor in front of, and things like that, which is nice. Okay. Then how to clean snow after your car, and so then what happened to this? Okay, yeah, I think this one here. Describe the video. Yes. So describe the video in detail. The video shows a man cleaning snow off his car using a snow brush. He starts by brushing the snow off the hood of his car, and moves to the windshield and so on. So then there's other one here, creative generative task. So,
everyone loves the way Skin Authority sunscreens feel when they go on. We incorporate our exclusive dry finish technology so that the sunscreen absorbs quickly without leaving your skin feeling greasy. We've also applied our multifunction design to our sunscreens to give you multiple results with just one application. Sunscreen Moisturizer SPF 30 is a broad spectrum sunscreen plus a daily moisturizer in one.
Okay, so you give this thing, and then...
everyone loves the way Skin Authority sunscreens feel when they go on. We incorporate our exclusive dry finish technology so that the sunscreen absorbs quickly without leaving your skin feeling greasy. We've also applied our multifunction design to our sunscreens to give you multiple results with just one application. Sunscreen Moisturizer SPF 30 is a broad spectrum sunscreen plus a daily moisturizer in one.
Generate a creative advertisement about this product that can be used for the product website. So say goodbye to sunburn and hello to healthy, glowing complexion with our new sunscreen product. It's pretty nice. So it did it for you, okay? So that's good. Okay, so here creative generative task. Does this have audio or not? So can you write a short poem about this video, okay? So, oh, sorry. Okay, so can you write a short poem from this video? Then he's going to do it, thinking, yes, I can write a short poem and say, in the garden, flowers bloom and sway. In the sunlight, they dance and play. Their colors are vibrant, their beauty rare, a sight to see, a joy to share. Their petals rustle in breeze. It's pretty interesting, right? So maybe it's copied from some other Shakespeare or something. So this is about. So who have seen this movie, this show? Everybody? No? Okay. I thought it's very popular. Okay, create a short fairy tale about this thing. Anyway, so then they have a special understanding task. So this is the video, and then you want to ask where is this video taken from. Then say New York City, and then so how do I do it? Okay, so a special understanding, describe the video. The video shows a person cutting of a peeling a red pepper, then you ask another question, how many slices are there, and so on. Temporal understanding. So given this video, and then you want to ask, describe the video, shows the man standing on snowy field throwing a javelin. He throws the javelin and runs toward it, picking it up, throwing it again. He then runs towards javelin and picks it up, growing it once more. The man then runs and so on. Okay, so temporal understanding. So this is making noodles, I think. Step by step describe the cooking recipe shown in the video. So you cooking a dish in a pan, they add ingredients such as noodles, spices to the pan, and then stir the mixture. The person then pours a sauce in the pan, and so on. And temporal understanding. Briefly describe the video. Video shows a woman who's grooming a horse with a brush. She's also seen talking to camera and so on. So I think this was pretty good. One of the first, probably the first paper doing the video VLM, and leverages the existing LLM and then fine-tune on video instruction data to capture temporal dynamics and spatial consistency relationship. And their contribution was that they have 100,000 video instruction, question answer pair, and also how to evaluate these video VLMs. Okay, so next thing we're going to talk about, again from the same group, is called PG-Video-LLaVA, Pixel Grounding Large Video Understand Language Models. So this was actually a paper we discussed last year, and this presentation is from these guys who took my class last year, and it's a pretty nice presentation actually. And this is on YouTube, so I'm going to use their slides. So the main thing here is that what we saw in the Video-ChatGPT, the input was the video, and you can do conversation. The output is text, but it does not have the grounding. Grounding means that you output and you put a bounding box or the segment the image, and that's called grounding. So this is the first paper which does that grounding, and pixel level grounding, which means like a semantic segmentation, and also it incorporates audio as compared to only video. Okay, and also give you the improved benchmark for video-based conversations model. So this is much more complicated model, and these are different pieces of this model. And as you see, it has this spatial temporal representation as we discussed, and LLM, but beside that they have grounding module and audio transcript. So we'll go through each piece. So language model, the input to that is these four things. Then it is using the Vicuna 13 billion, and it has the 4 params: the text system command, text user query, video tokens, and text audio transcript. So it is shown here, and this is system command, user query. This is the video spatial video representation, audio transcript. That goes to language model and give you a response like this. So then we look at the system command, which is kind of standard. That will be system commands like this, that you are the PG-Video-LLaVA, large vision language assistant. You are able to understand the video content that the user provides and all this thing, and follow the instruction carefully. So you have to tell these things, right? So then user will say, what's the person doing in this video? So then this is the new thing, which is this audio tagging. So the way it works is that we have the given audio is a one-dimensional signal, give it to this thing, voice activity detection. So it will detect if there is something going on. So input video, voice activity detection will come out the pieces where there's something happening. They may be quiet, so they want to remove those. And they will cut those out, merge them, so you'll have batch like this. And it basically identifies the pieces, segments in the audio which has a speech. And they will remove out the pieces which has some music and so on, because it's not going to understand music. If some noise, they will take it out. And they will remove those and then merge them and align with context video so that you can look at the useful information. Okay, so then after that they want to get this whisper, and which will get you the transcript. Whisper is get audio in and the transcript out, the language out, which is like ASR, automatic speech recognition. Then they have the audio tagging module and phoneme module. So Whisper will take these pieces of audio and give you transcript, speech to transcription generation. Audio tagging module will produce different tags. As we were doing earlier, tags that give an image, what are the things present. So here it will give you the tags for the audio, and it will look at 3 top audio classes. And if the speech is not among the 3 prediction, then segment is ignored because that's not useful. Okay, so also they apply some threshold that if the probability of speech that segment being music is higher than being a speech, or if the subtraction of these is above some threshold, then you ignore that particular segment. So this is the way it works, that you get some text here, get a transcript, and this will filter out those segments and only get those segments and corresponding transcript, which is useful. Okay, so then they want to align the transcript, which are the words, and the segments, because they may be not synchronized. So that's what's called dynamic time warping, that you can warp it so that they are aligned. And so the phoneme, as you know, is the smallest piece of the speech, and you can distinguish one from other, and then you can temporarily align these with the transcript, and that's what they are doing here. You have phoneme model, you have whisper, and you get this particular piece of audio is actually saying that's this particular piece of audio saying right, and so on. It's pretty interesting the way they do.
The video also aligns like the audio?
Yeah, so right now they are just aligning the audio, but audio comes from the video. So, but this is the audio part. Okay, so now after all that, then you will get, suppose this is a transcript from Whisper, and so there was nothing said. The human look at this, thanks for watching. They just remove it. It's not correct. Okay, so it's a hallucination. This is another example where this is all in music. Okay, so they just get rid of that. So that's a filtering process they do. Okay, so and then this one, it transcript say 1.5 whatever numbers, and this is useful. It's not there, so it's a garbage. They remove that. So that's the way they do the filtering. Okay, so now we already discussed this, how you take the frames, which are shown here, and you encode that using your clip. Each frame is encoded like an image, and they do spatial pooling, temporal pooling, and combining all those things. So I'm going to skip those. It's the same thing I explained before already. Okay, so then the final part is that I think we can go through this one. Yeah, so this one. Now there's a left part. So because not only we want to be able to take the video and audio and answer in the text, but we also want to do grounding the output will be like this. So, question is, what is the person in the video doing? The answer is the person in the video is a man who is sitting on the ground and petting a lion. So that is one. That's Video-ChatGPT will do that. But in addition to that, we want to get this grounding. So we want to say where is a person and where is a pet and so on. So that's a segmentation, pixel-wise segmentation. That's why I call pixel PG video, pixel grounding. Okay, and this part which does that. So to start with, you take a video, you do the scene detection, because the video can have a lot of things changing, scene changes. So you want to segment it and get each scene, because this is one piece, then the next one is different. So you want to separate them out. And scene detection, that's what you do in movies and so on. Okay, so now once you get this thing, and then you want to you want to do the tagging of that for this one, and you get the lion, mane, mountain for this particular clip or segment, and then you get this one, and now you want to, using those tags, you want to ground it. You want to find this dyno grounding, this dyno method, which will detect those objects which you input, and the output will be like this, because there were lion, there's a mane and mountain, so 3 bounding boxes. So as you see, all this expert vision models, the traditional models we use, are being used in VLM here. Okay, so once we have this, now we want to do pixel-wise, because this is a bounding box, right? It's not really segmentation. So then we use segment everything, same model, to take this as input, and output will be like this one. Now we have a contour and so on, which is good. Okay, so then final one is that we can actually take this one and apply a tracker. Now you are actually tracking also from frame to frame. It's the same label, and this is the input going to this model. So, so we did this in a way as a vision part. Now we want to reconcile with the text part, right, the vicuna. So what we do the entity matching. So, so we get lion, mane, mountain, and then from the LLM response, say the person in the video is a man who's sitting on the ground and petting a lion. So you want to reconcile that. And vicuna will match. Well, this is one piece of information, this is another piece of information, but like mountain is missing, is not common, so it will remove it. It's a lion and mane. Okay, so then it will put a segmentation on the mountain, on the lion and the mane, and make sense, because it is grounding what is described in the response. So that's it. So this, they go through training. Now, good thing about these training of these visual language model is you don't need many epochs. You just use about 2 or 3 epochs, because already trained, the large language model is trained, and you have nice encoder, which is already trained. So you just want to train that projector and maybe fine tune a little bit. So they use this 100K video instruction drive as they did for ChatGPT from ActivityNet, 3 epochs and this learning rate and all this thing. So then they want to also evaluate and compare with this score and so on. So one thing they did, that they replaced GPT 3.5 with vicuna for this evaluation. Because GPT 3.5 is not open, so it's a closed model, and vicuna is open source, so which is good. So same kind of thing: correctness of information, detailed orientation, contextual understanding, and temporal understanding, and so on. Okay, so this we went through already, and this these are instructions you give it to the large language model to come up with a question answer pair. And they use this activity net as we did before. And now you can evaluate this model just on the, similarly, the question answer pair for the video, no grounding or anything. And they got improvement over Video-ChatGPT, right? So these are the comparison with Video-ChatGPT. And now also here you see that if you have the larger model, the 7 billion and 13 billion will make a more difference, okay? So it's a better model. So that is, I think you can say if the language model is larger, then you get better results, and this is shown here. So then now we want to actually evaluate the the grounding part, because that's a new thing here. So that's still a hard problem, and it's still a open research problem. So one is in order to grounding, we need to have all the ground truths, right? We need to have bounding boxes. We need a pixel-wise annotation video. It takes a lot of effort. So they look at the vid-OR data set, which has 10,000 videos, and it has bounding boxes. And then from there, they got the captions. That is about 5,000 videos, and this is called vid-STG. So then they look at another data set, HC-SVTG, and for this one, there's no caption, and they generated captions using Vicuna 1.5. So using that, now you want to evaluate. Now evaluation of the grounding is easy. We use it all the time in computer vision. You must have learned in the 5415. So this is the question: who is sitting next to lion? The man is sitting next to lions, and so go to the Vicuna, and it gives you man as the, which goes to the grounding module. It outputs the bounding box, dino grounding, and then this is the ground truth. So now you want to look at the bounding boxes intersection or union. How much is intersection between ground truth and what is detected and divided by the union, which means what percentage of this is correct. So that's a standard metric we use, and that's what they're using. In that one, they show that they can do pretty good, these numbers compared to these other models, okay? So of course now you can do the standard, the generative, just outputted text, not the grounding. So for which question answer, data set, MSVD QA, 520 videos, MSR VTT, about 3,000 videos, TGIF, about 8,000 videos, and ActivityNet, about 500 videos. So this is question answer pair. Now you want to evaluate this model based on that, okay? And they talk about how these question answer pair were generated. So then you put a question, you put an answer, which is a ground truth, and you put the answer which is predicted from model and give you correct yes or no. It also gives you a score, how good it is from 0 to 5, as we talk about that. According to this, also they do pretty well compared to Video-ChatGPT. And so because in a way, this PG-Video-LLaVA is more generalized compared to Video-ChatGPT. Video-ChatGPT is a special case of this because this one does the grounding also, okay? The Video-ChatGPT doesn't do grounding. So again, these are some of the examples. Describe the video and say the video shows graph performing a trick by standing on the board and so on like that. But it will, do the grounding. So it will put bounding box when it's talking about the water, talking about the graph, and so on. So which is, I think, good. And here's also a statue, put a bounding box on a ship. water body, a boat, and so on. So then the last part is audio, because they use the audio also. So they want to show that what's the advantage of audio. So they put this video, and then they ask, can you suggest a title for this video clip? Now, audio is not present, so it will come up with, because the, in this video, there are these people, and these are two famous people, right? This is Sam Altman, and this is Friedman, Alex Friedman. He does a very good podcast. So now, when they look at the audio, then they come up with a better title. Say, well, the future of AI, a discussion on ChatGPT-4 and ChatGPT. Okay? So here also, again, the same show, Friends. So they are talking about that what is Ross complaining about? Ross is complaining about a taste of beer he's drinking and so on. But then when you do audio, then it's someone eating a sandwich, because sandwich was mentioned, the audio, which is here. So that's more relevant compared to just video information, visual information, because you need all these things. Okay, so so of course there are some failure cases. They were not able to put the correct bounding boxes and so on. So you can look at that. Okay, so in conclusion, this is a novel video-based conversation model with pixel grounding. They are able to add the audio and filter out some of these pieces, segments which are not useful, and then they can put a bounding box with a pixel-wide grounding in videos, and they replace GPT 3.5 with Vicuna.